Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the IoT enabled technologies part 2 under the course Principles of IoT. The slides are prepared by referring the textbooks Internet of Things, a hands-on approach, authors Arshdeep Bagh and Vijay Madsetti, publication Universities Press. So in this session, we are going to discuss the IoT enabled technologies. Under this, we are going to see wireless sensor networks, cloud computing, big data analytics, communication protocols, embedded systems. So in the last session, we have discussed the wireless sensor networks and cloud computing. The remaining technologies we will see in this session. So IoT is enabled by several technologies, including wireless sensor networks, cloud computing, big data analytics, embedded systems, security protocols and architectures, communication protocols, web services, mobile internet, and semantic search engines. So out of this, we are going to mainly focus on wireless sensor networks, cloud computing, big data analytics, communication protocols, and embedded systems. So first, the third IT-enabled technologies is big data analytics. So the big data is defined as a collection of data sets whose volume, velocity, that is temporal variation or variety, is so large that is difficult to store, manage, process, and analyze the data using the traditional databases and data processing tools. Big data analytics involves several steps starting from data cleansing, data munging, that is wrangling, data processing, and visualization. Examples of big data generated by IoT system are sensor data generated by the IoT system for weather monitoring station, where it is going to sense the variation in the temperatures or humidity. So periodically, so large amount of or huge amount of data will be captured by these IoT sensor systems for weather monitoring stations. So the mission sensor data collected from the sensors in industrial and energy systems for monitoring their health and detecting failures. So as these sensors are going to continuously monitor, and every time it is going to capture the data which it is sensed, so it is also going to produce huge amount of data. So big data analytics refers to the methods, tools, and applications used to collect, process, and derive insights from varied high volume, high velocity data sets. These data sets may come from a variety of sources such as web, mobile, email, social media, and network smart devices. They often feature a data that is generated at a high speed and varied in form, ranging from structured to semi-structured to unstructured, that is, images and audio files. Some examples of big data generated by IoT systems are the sensor data generated by IoT systems such as weather monitoring stations, data generated by IoT systems for location and vehicles, data generated by retail inventory monitoring systems. So, health and fitness data generated by IoT devices such as wearable fitness bands, data generated by IoT system for location for tracking of the vehicles, data generated by retail inventory monitoring systems, So the characteristics of a big data mainly includes volume, velocity, which is nothing but temporal variation, and variety, different types of elements which you are going to be sense. So the data value, where the process provides the amount of data and the form of data that we are going to be placed in the volume quantity. The data value may be in terabytes, that it can be a records type, transaction type, tables, and files. Whereas velocity, the velocity provides the time at which the data is collected and arrived, analyzed. So the data velocity, it can be like a near time, a real time, streams, and batches. Variety provides the type of a data collected. The variety of data can be structured, semi-structured, unstructured, or mixed of all these three qualities. So these are the main characteristics of a big data. So now we will see each and every characteristics in detail. Volume. So though there is no fixed threshold for the volume of the data to be considered as a big data, the term big data is used for massive scale data that is difficult to store, manage, and process using a traditional databases and data processing architectures. So the volume of the data is generated by modern IT, industrial, and healthcare systems. Velocity. Velocity is another characteristics of big data and the primary reason for exponential growth of data. Velocity of data refers to how fast the data is generated and how frequently it is going to be varies. Variety. So the characteristics variety refers to the form of the data such that it can be structured or unstructured data, which includes text, image, video, and sensor data. The different types of big analytics, like descriptive analytics, diagnostics analytics, predictive analytics, prescriptive analytics. So descriptive analytics, this analyzes and summarizes the past data into easy readable form. It helps in creating reports like company's revenue, profit, sales, and so on. Also, it helps in tabulation of social media metrics. Use case, the Dow Chemical Company analyzed its past data to increase the facility utilization across its office and lab space. Using a descriptive analytics, Doe was able to identify unutilized space. This space consolidation helped the company to save nearly the US $4 million annually. The next one is diagnostics analytics. It is done to understand what caused a problem in the first place. Techniques like drill down, data mining, and data recovery are all examples. Organizations use diagnostic analytics because they provide an in depth insight into a particular program. Example by use case. An e commerce company report shows that their sales gone down, although customers are adding products to their carts. This can be due to various reasons like the form did not load correctly, the shipping fee is too high, or there are not enough payment options are available. The next one is a predictive analysis. It looks into the historical and present data to make predictions of the future. So the predictive analysis use the data mining, artificial intelligence, and machine learning to analyze the current data and make predictions about the future. It works on predicting customer trends, market trends, and so on. Use case PayPal determines what kind of precautions they have to take to protect their clients against any fraudulent transactions. Using predictive analysis, the company uses all the historical payments data and use behavior data and builds an algorithm that predicts the fraudulent activities to find the reason. Next one is prescriptive analytics. This type of analytics prescribes the solution to the particular problem. Prescriptive analysis works with both descriptive and predictive analytics. Most of the time, it relies on the artificial intelligence and machine learning. Examples by using case prescriptive analysis can be used to maximize the airline's profit. This type of analytics is used to build an algorithm that will automatically adjust the flight's fares based upon the numerous factors, including customer demand, weather, destination, holiday season, and oil prices. So, the big data analytic tools. Here are some of the key big data analytic tools. Hadoop. It helps in storing and analyzing the data. MongoDB. It is used on data sets that change frequently. Talent. It is used for data integration and management. Cassandra, a distributed database used to handle chunks of data. Kafka, a distributed streaming platform that uses the fault-tolerant storage. Spark, it is used real-time processing and analyzing large amounts of data. Storm, it is an open source real-time computational systems. So these are the few tools which are used for big data analytics. Next, we will see the big data industry applications, e-commerce, marketing, education, healthcare. So e-commerce, predicting customer trends and optimizing prices as a few of the ways e-commerce uses big data analytics. Marketing, big data analytics helps to drive high region of interest marketing campaigns, which results in improved sales. Education, used to develop new, improve existing courses based upon the market requirements. Healthcare, with the help of patients' medical history, big data analytics is used to predict how likely they are to have the health issues. Medical and entertainment, the big data is used to understand the demand of the shows, movies, songs, and more to deliver a personalized recommendation list to its user. Banking, customer income and spending pattern help to predict the likelihood of choosing various bank offers like loans and credit cards. Telecommunications, it is used to forecast the network capacity and improve the customer experience. Government, big data analytics help governments in law enforcement, among other things. So, the benefits and advantage of big data analytics: risk management. Example, Banco de Oro, a Philippine bank company, uses big data analytics to identify fraudulent activities and dispenses. The organization leverages it to narrow down a list of suspects or root cause of the problems. Product development and innovations use cases. Rolls-Royce, one of the largest manufacturer of jet engines for airlines and armed forces across the globe, it uses big data analytics to analyze how efficient an engine designs are if there are any need of improvements. Quicker and better decision making within the organization use case. Starbucks use the big data analytics to make strategic decisions. For example, the company leverages it to decide if a particular location would be suitable for a new outlet or not. They will analyze several different factors such as population, demographics, accessibility of the location, and more. Improve customer experience. Use case. Delta Airlines use big data analytics to improve customer experiences. They monitor tweets to find out other customers' experience regarding their journeys, delays, and so on. The next IoT enabled technologies, communication protocols. So, communication protocols allow devices to exchange data over the network. These protocols define the data exchange formats, data encoding, address schemes for devices, and routing of the packets from the source to destination. The other functions of the protocols include the sequential control, which is nothing but ordering of the packets and determine the loss of the packets. Flow control, it controls the rate at which the sender is sending the data so that the receiver or the network is not overwhelmed, and retransmission of the lost packets. So communication protocols you can have for IoT system like Bluetooth LE, Google Thread, Wirepass Mesh, NB IoT, LoRaWAN, SIGFAS, and Jetway. So these are the viable communication protocols that can be integrated into the Internet of the Things. The last IoT enabled technology we are going to discuss is embedded system. So an embedded system is a computer system that has computer hardware and software embedded to perform a specific task. In contrast to the general purpose computer or personal computers which can perform the various tasks, embedded systems are designed to perform a specific set of tasks. The key component of an embedded system include a microprocessor or microcontroller, memory, network units, input-output units, and storage. So the ideal structure of an embedded system is we are going to have an embedded computer which is composed of both software and hardware. The inputs mostly will have the sensor data. We are going to be acquire the sensors data for the physical quantities. Then output variables, it is like a actuators, any output device to drive like motors, LCD screens, or a transmitter kind of thing. Then it can be linked with a user interface as well as it can be linked to other systems. So the embedded devices are the objects that build the unique computing system. This system may or may not connect to the internet. An embedded device system runs as a single application. However, these devices can connect through internet connection and able to communicate through other network devices also. The embedded system can be of type microcontrollers or microprocessor types. The essential components of the most of the embedded systems is a reduced instruction set computer family microcontroller like Motorola 68HC11, PIC 16F84, or Atmel 8051 microcontrollers, and many more, which we can use as the processing component in an embedded systems. Some embedded systems have a specialized processor such as a digital signal processing, graphics processor, and other application specific process. So this specific process will be act as the coprocessor along with the main general purpose processor. So DSP processor, it is mainly used for processing of the signals, either it may be a text or audio or video kind of the things. Graphic processor for acceleration for the video gaming. Embedded systems run embedded operating systems such as real-time operating systems called as ARTAs. Embedded systems range from low-cost miniaturized devices such as digital watches to devices such as digital cameras, point of sales terminals, vending machines, appliances like washing machines, ACs, etc. So these slides are prepared from these resources. Few concepts and diagrams are drawn by going through. These are the web sources which I used. So this you can use as a resources. So in this we have discussed few IoT enabled technologies. So in the last session we have discussed wireless sensor networks and cloud computing. In this session we have discussed the big data analytics, communication protocols, and embedded systems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.